Let us start linear inequation in one variable, chapter 4 of ICSE Class 10th. In our daily life, we come across a situation where we cannot express our mathematical views in the form of equation. That is, there are 10 questions in a paper. A student A says that he can solve only 5 questions. B says that he can solve less than 5 questions. C says that he can solve more than 5 questions, where D says that he can solve at least 5 questions. The student E says that he can solve at most 5 questions. These statements can be expressed mathematically as follows. Student A, whose capacity to solve the question is confirmed that it is equal to 5. So 5 questions only. But the B, he says that he can solve question less than 5. Means less than 5 means he can solve question number 1, 2, 3 and 4. Only 4 questions he can solve. Maximum. C, whereas he says that he can solve greater than 5. Means he can be able to solve 6 questions, 7 questions, 8 questions, 9 questions and 10 questions completely. Now D says that, you see, D says that he can solve at least 5 questions. Means, at least means he is confirmed that he will be able to solve. He will be able to solve 5 questions, 6 questions, 7 questions, 8 questions, 9 questions, 10 questions. Means at least. At least means minimum he will be able to solve 5 questions and he can exceed also. He can be able to solve the total question 6, 7, 8, 9, 10 and so on. But whereas E says that at most he can solve only 5 questions. Means he will be able to solve 1 question, 2 questions, 3 questions, 4 questions, 5 questions at most. Means below 5 and below 5 he will be able to solve the questions. So you see, here we are getting the solution in the solution set we are getting. Let us move to some other example. You see that as per the definition, 2 real numbers are 2 algebraic expressions related by the symbol less than, greater than, less than or equal to, greater than or equal to form an inequality. Algebraically we can say that is just see ax plus b is less than 0. This inequality is known as strict inequality. Ax plus b is greater than 0. This is known as strict inequalities. Ax plus b is less than or equal to 0. There is slack inequalities. Ax plus b is greater than or equal to slack inequalities. Now see the replacement set or inversal set means there is a bigger set of set is given. From there we have to find out our solution set. Here I have represented by Venn diagram. That is complete this figure surrounded by rectangle, that is inversal set or you can say the replacement set. From there we have to choose the solution set are known as truth set also. Is it called truth set? Or these sets are solution set or truth sets are the subset of inversal set or replacement set. Inequality postulate. Let us move to the what are the rules? What are the rules for inequality? And that is known as inequality postulate. You see, same number, either plus or minus, can be added or subtracted from both the sides, and ultimately there will be no change in the sign of inequality. Same number, same positive number, you see, same positive number can be multiplied or divide both sides, and ultimately no change in equality. Same negative number multiplied or divide both sides, there the sign of inequality is reversed. We have to pay a little bit more attention here, because while we are multiplying negative sign, so at that time multiplying or dividing both sides, the sign of inequality will be reversed. If both the sides are positive, means left hand side and right hand side, both sides are positive, on squaring there will be no change in sign of inequality. If both the sides are negative, on squaring the sign of inequality is reversed. On transformation, that is, if you move to the expression from left hand side to the right hand side or right hand side to the left hand side, you are changing the place of the expression from left hand side to right hand side or right hand side to left hand side. The sign of inequality is also reversed. This process is known as transformation. It is separate from the transposing. Transposing means we are just shifting particular things, let it be the constant or variables, from left to right side. But here complete, we are just reversing the complete process. At that time, the sign of inequality will be reversed. Let us proceed. ICSE Class 10th, Chapter 4, Exercise 4. You see the page number CH4-6. The first question is, on a bargain counter, the shopkeeper puts label on the various goods showing their prices. Rupees P, where P belongs to the real number. Write a mathematical sentence for each of the following labels. More than rupees 7.50. You see, more than 7.50, I have expressed it here. P is greater than 7.50. Now, not less than rupees 10 means P is greater than or equal to 10. Not less than rupees 10. You see, not less than, but it can be expressed like this. Inequality, sign of inequality is greater than or equal to 10. Not more than 22. So, the language, mathematical language, you can say not more than means not greater than 22. Here, P is less than or equal to 22. D, that less than 11 means P is less than 11. These are the answer of question number 1. Now proceed to the question number 2. You are given the following numbers, that is minus 2.6, 5.1, minus 3, 0.4, 1.2, minus 3.1, 4.7. Now fill the blanks. We have to fill up the blanks here. This is the A part and B part. Here A part is mentioned here. The A is inside the curly bracket, that is x, such that x is greater than or equal to minus 3. means greater than or equal to minus 3 means minus 3 is included. So minus 3, if you just go on the number line, you have to move from minus 3 to right hand side. So you see here I have this set is known as replacement set. Now this is solution set. So minus 3, I have brought it minus 3, minus, you see minus 3, minus 2, you see minus 2.6 here. Again you see 0.4, 0.4, 1.2, 4.7, 5.1. These are the solution set of the question number 2A part. Now come to the B part of the question number 2B such that x is less than or equal to 1. Means we have to choose all those numbers on the number line which will come to the left hand side of the 1, means included 1. But here the replacement, we have to choose the answer from the replacement set. These are the replacement set elements. So the minus 3, minus 2.6, 0.4 and 1. This is the solution set of the question number 2B part. Now proceed to the question number 3. If a replacement set is minus 2, minus 1, plus 2, plus 4, plus 5, plus 9, what is the solution set of each of the following mathematical sentences? X plus 3 by 2 is greater than 5 by 2. Now here we have to solve it. You see, I have written first questions. X plus 3 by 2 is greater than 5 by 2. So, in order to remove this denominator part, what I have done here, that I have multiplied all the elements, all the terms of left hand side and right hand side by 2. So we are getting 2x plus 3 greater than 5. Again 2x plus 3 minus 3, 5 minus 3. The greater than sign is there, sign of inequality is as it is. Now here minus is added to both the sides. Why I have added it? I have added it to remove, to cancel this 3. So ultimately we are getting the 2x greater than 2. So again just to divide by 2 to both sides, and 2 is positive. Hence the sign of inequality will not be changed. So x is greater than 1. So we have to find out the value of x which should be greater than 1. Means from here we will see which are the values which are greater than 1 is, that is plus 2, plus 4, plus 5, plus 9. Yes, this is the solution set I have written here. Now question number B part of the question number 3, that is x minus 4 equal to minus 3. So what I have done here, I have added minus plus 4 to both the sides. Why I have added minus plus 4? Because I want to, my aim was to remove minus 4. So I have added plus 4 to both the sides. So we are getting here x equal to minus 3 plus 4. So ultimately we are getting the x is equal to plus 1. So the answer will be plus 1 only. Now C part, 2x minus 5 is greater than or equal to 10. So again, while you are transposing this minus 5 to this side, it will be added here. Now 2x is greater than or equal to 15. So ultimately x will be greater than or equal to 15 by 2. That is, x is greater than or equal to 7.5. So we will see in the replacement set what are the values which are greater than or equal to 7.5. You see, only 9 is the number. So therefore we will just write down the solution set will be plus 9. Now proceed D. The D is 3y divided by 2 less than or equal to 5 by 2. So 3y by 2 is less than or equal to 5 by 2. This 2 and 2 will be cancelled. So we are getting 3y is less than or equal to 5. So ultimately y will be equal to less than or equal to 5 by 3. So we will just find out the values which will be either it will be equal to 5 by 3 or it will be less than 5 by 3. So we are getting from the replacement set, that is minus 2, minus 1, plus 1. These are the solution set for the question number D part, question number 3. Now E part. You see, the E part states that four x square equal to 16. So the x square will be equal to 16 by 4. Therefore it will be equal to 4. So x square will be equal to 2 square. So x will be equal to plus minus 2. Here I have mentioned x is equal to plus minus 2. So in solution set I have put minus 2 and plus 2 are the two solution and these are the solution set. Now proceed to the question number 4. List the solution set of 30 minus 4 inside the bracket 2x minus 1 is less than 30, given that x is a positive integer. Here you see the list the solution set of 30 minus 4 in bracket 2x minus 1 less than 30, given that x is a positive integer. So 30 minus 4 inside the bracket 2x minus 1 is less than 30. So you see the 30 is there on the left hand side as well as on the right hand side. I have cancelled it. So we are left with minus 4 inside the bracket 2x minus 1 less than 0. Now multiplying both sides by minus 1 we get, you see, we are getting 4 in bracket 2x minus 1. Now here the sign of inequality will be changed because I have multiplied by minus 1. So the sign of inequality, previously it was less than, now it has become greater than 0. Now transpose or you see 8x minus 4 is greater than 0. So 8x will be greater than 4. X will be greater than 4 by 8. That implies that x is greater than 1 by 2. The solution set, we have to find out what are the values from the replacement set. That is 1, 2, 3, 4 and so on. Now proceed to the question number 5. Replacement set is given. Mathematical sentences are here. We have to find the solution set. You see, just I am reading it. If the replacement set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, What is the solution set of the following mathematical sentences? First is x plus 4 by 3 equal to 7 by 3. I have written here. So x will be equal to 7 minus 4 by 3. 7 minus 4 by 3. These are the two like fraction. So I have just keeping the denominator same. I have subtracted from the numerator part, that is 7 minus 4. The result will be 3 by 3. That will be equal to 1. So the solution set will be 1. Now proceed to the question, B part of the question number 5. 2x plus 1 less than 3. So once you just transpose plus 1 to this side, so the 2x will be less than 2. So x is less than 2. Sorry, x is less than 1. So I will have to see what are the numbers which are less than 1. You see, we are getting only 0. So that is why I have written in solution set 0. Now C part, x minus 6 is greater than 10 minus 6. You see, this minus 6 and minus 6 will both be cancelled. Now we are having x is greater than 10. So you just see in the solution set, is there any value which is greater than 10? In the solution set, you see, from 0 to 9, there is no value. That is why I have mentioned it. It is a pi set. Solution set will be equal to pi set, null set or empty set. Now the D part, x plus 5 is equal to 20. So x will be equal to 15. And we will find out the solution set from the replacement set. Is there any number which is equal to 15? No. So that is why I have mentioned here it is a pi. Now proceed to the E part. 2x plus 3 is greater than or equal to 17. So the 2x will be greater than or equal to 14. X will be greater than or equal to 7. You see, greater than or equal to 7 means including 7. So you just find out the number 7, 8, 9. Now here see the solution set is 7, 8, 9. This will be the answer for E part of the question number 5. Now proceed to the question number 6. You see A, x belongs to 2, 4, 6, 9 and y belongs to 4, 6, 18, 27, 54. Form all ordered pair xy such that x is a factor of y and x is less than y. You see here, I have written here the x belongs to 2, 4, 6, 9, y belongs to 4, 6, 18, 27, 54. Form all ordered pair xy such that x is a factor of y and x is less than y. So you see the 2 from x, 4 from y. So 2, 4, 2, 6, 2, 18, 2, 54, 6, 18, 6, 54, 9, 18, 9, 27, 9, 54. These are the answers of question number 6A part. Now the B part. Find the truth set of inequality, that is x is greater than y plus 2. Means where x and y belong to these order pair 1, 2, 2, 3, 4, 5, 1, 7, 3, 5, 6, 5, 6 and 6, 5. These are the order pair. So we have to x is greater than y plus 2. X is greater than y plus 2. So we have to see if we add 2 to the y part, it should be x should be greater than this portion. Now you see, if you add 2 to this 1, it will be 1 plus 2, that will be 3. So 5 is again greater than 3. Now here you see 7 and 3. If you add 2 to 3, again the 7 will be greater than 5. That is why I have taken this two ordered pair, that is 5 1 and 7 3. This will be the answer for question number 6. Now question number 7. Find the truth set, means solution set of the following open sentences. Replacement sets are given against them. You see, 5 by x is greater than 7. Such that the solution set is given 1 and 2. So this can 5 by 1 means 1 here, from here you take 5 by 1, and should not be, it should be greater than 7. Is it possible? You see now here 5 by 1 is not greater than 7, so not possible. Now you see in the second case 5 by 2 again, 5 by 2 again is greater than 7. So not possible again. The solution set is 5. Therefore, solution set is 5, means empty set will be there. Now the second part, 5 by x is greater than 2. So solution set is, replacement set is given, or universal set you can say, 1 2 3 4 5 6. So 5 by 2 is greater than x. This implies that if you solve this portion, it will be 2 and 1 by 2, means 2 and a half is greater than x. So we have to choose the value of x such that 2 and a half should be greater than the value of x. Means we have to find out those values of x which are less than this. So the solution sets are 1 and 2. Now proceed to the question, third part. X square is equal to 9. So x will be equal to plus minus 3. Solution set we have to find out. This is the replacement set is given. So solution set will be minus 3 and 3. This will be the answer. Now fourth part. X plus 1 upon x is equal to 2. So the replacement set is given, that is 0 1 2 3. So x square, you see, just x square plus 1 equal to 2x. Again you solve it, x square minus 2x plus 1. Again it can be written like this, that x minus 1 whole square is equal to 0. So x minus 1 is equal to 0. Again the x will be equal to 1. So our solution set will be 1. Now fifth part, 3x square is less than 2x. So we have to choose the answer from the replacement set, that is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So here you see 3x is the cancel the x1 from this side and this one. So we'll get ultimately the 3x is less than 2. So again the x is less than 2 by 3. So we'll have to see that the value of x will be such that it should be always less than 2 by 3. So let us go and see. The solution set is given here. We have to find out near out. You see, just if you solve it in a decimal form, then it will be equal to 0.6. Is there any number which is 0.6? No. So that is why it is written that 5. Again the sixth part, 2 inside the bracket x minus 3 is less than 1. And in replacement set is given, that is 1, 2, 3, 4 up to 10. So x minus 3 is less than 1 by 2. Again I have transposed the minus 3 to this side. So it will be equal to x is less than 3 plus 1 by 2, that will be equal to 7 by 2. So that is again 3 and 1 by 2. X is less than 3 by 2, 3 and 1 by 2. So the solution set will be 1, 2 and 3. This will be the answer for sixth part of question number 7. Now proceed to the question number 8. The sum of the length of any two sides of a triangle is always greater than the length of its third side. Let x and x plus 1, x plus 2 be the length of the three sides of the triangle. First part, write down the three inequations in x, each of which represent the given statement. And second part is list the set of the possible values of x which satisfy all the three inequations obtained in your answer to the part 1 above, given that x is an integer. Now you see there is one triangle whose sides are x, x plus 1, x plus 2. So as per the statement given that the sum of the two sides must be greater than third side. Here I have mentioned x plus 1 should be greater than x plus 2. I have solved it. 2x plus 1 is greater than x plus 2. Ultimately x is greater than 1. So the solution for this means the value of x will be equal to 2, 3, 4 means greater than 1. So it is mentioned here 2, 3, 4 and so on. Now the second part, x plus 1 and x plus 2 is greater than x, means x plus 1 or x plus 2 should be greater than third side, that is x. Again just solve it. 2x plus 3 is greater than x. X plus 3 is greater than 0. Just transpose this one x. So 2x minus x will be equal to x. So x is greater than minus 3. X is greater than minus 3. The value solution set will be minus 2, minus 1, 0, 1, 2, 3 and so on. Now third situation, that is x plus 2 means this side and this side. X and x plus 2 should be greater than x plus 1. It will be equal to 2x plus 2 greater than x plus 1. Again x is greater than minus 1. So therefore the solution set for this will be equal to 0, 1, 2, 3 and so on. Means the value of x should be always greater than minus 1. Now the second part, the solution set, that is 2 plus plus 3 plus 4. These are the solution set for the first part of the first question, and second part 2, 3, 4 is the intersection of the above solution sets. 2, 3, 4 is the intersection of the above solution set. You see this one and this one. The intersection we have taken for this solution. Okay, that's all.